And I'm going to do all my lectures on here. It's going to be basically like lecturing on the whiteboard, but I'm going to be, and it'll, yeah, like a modern whiteboard. But, and then the benefit of this, yes, thank you. Keep shutting up. You did really well at first. So the benefit, though, is that after class is over on D2L, I can post PDFs of everything that I wrote, so you can access my notes. And I can on YouTube, I can post videos of, you'll see the pen moving around and hear my voice. So it's really nice if you miss class, because you can basically like attend class whenever you want, just looking at the YouTube video. And if you miss something and you want to go back and something didn't make sense the first time and you want a second crack at looking at it, you can look at the lecture again. So that's why I'm going to do it on here. But I think what you should do is just take notes, like everything I write down on here that appears up there. You should put that in your notes, just the same way you would if someone was lecturing on the whiteboard. And what I'm going to start with today is just going through the syllabus, talk about the structure of the class, and then when that's done, I'll start getting into some material, but probably half or more, I don't know, half the class or something is going to be just describing the format of the class, how things are going to work. Okay, so the syllabus is on D2L, and so far I'm pretty sure none of you have access to D2L, which is sort of a pain, but that's happened before. I'll talk to Meredith or talk to IT or something, and hopefully we'll get that ironed out pretty soon. This is right now what the D2L page looks like. As things get added, I'll try anything new that I put up here, I'll try to make announcements. So the first thing you'll see when you log into the class on D2L is what's new on there, what the assignment is for the day, that kind of thing. All of the documents that I put on D2L are going to be in the content section, probably just like all your other classes. And right now under content, the only thing in there is there's a category called course information, and that's where the syllabus is. Later today, I'll put up an assignment, and I guess if you're not on D2L by today, I guess what I'll do is email it to Meredith, and she can distribute it to you, and I can get stuff to you that way until the D2L thing gets ironed out. Okay. So let's go through the syllabus. This is Calc 1 with, no, Physics 1 with Calculus. And calculus comes up in a bunch of ways in physics pretty naturally, but I think you'll find that so we're going to use calculus a lot, but we're not going to use hard calculus. I don't think understanding the math of any of this is going to be that difficult. Like mostly it's going to be the challenge of just understanding the physics and retaining a lot of concepts related to physics, and calculus will come up from time to time. My name is Gaio Lakin. Please call me Gaio. I have a PhD, but it's not in physics. It's in engineering mechanics, kind of like engineering math. In the type of engineering I do, you had to take a lot of physics, but what I don't have any expertise in is like modern physics, the crazy physics where particles are over here and over here at the same time, and then you like measure it and then it chooses where to go. And so like quantum mechanics and relativity, that's where all the wacky stuff happens, and that's not really my area. So like sometimes people will have questions like, oh, I heard about this new physics thing and I know about some of it just like from reading Scientific American or whatever, and like I'd be happy to talk to you about the stuff that I understand, but that's not really like my area of expertise. I just sort of have a layperson's understanding of that stuff. But this kind of physics, the kind of stuff we do in these early classes, I've used a lot of this stuff a lot, and I know this stuff well. So to get a hold of me, the easiest way is email, and there's my email address. You can also call that phone number and leave. I don't even have a phone in my office, but you can call that number and leave a message, and I'll get a email saying I have a message, and you can get in touch with me that way. But email is the most direct. Office hours. I'm not sure why I formatted it this way, but I'm going to have office hours Monday through Thursday from 11 to 12, basically, in the tutoring center at Normandale. That probably isn't very useful for most of you. I mean, maybe they'll be like on yours. I think my spring break doesn't match up with yours. So there's going to be a week where you're coming to classes here and you don't have, you don't have school, don't have at your other school. So maybe that time, those office hours will be useful. But most of the time, the ones that'll be useful for you are the times that I come to Meredith's room at Jefferson. How many of you go to Kennedy? Okay. I can also, so it's more convenient for me to go to Jefferson, and that's why I'm planning to make that sort of my home base. But we should definitely make appointments for me to come to Kennedy occasionally too. But we'll just make those appointments on a case-by-case basis, and then of course, if you have a way to get to Jefferson, you're always feel free to come to these things at Jefferson. But we'll figure out a way to make that work. I haven't talked to Meredith about whether Tuesday and Thursday from 3 to 4 would work with her, but for now, that's what I'm gonna sort of hope for. Okay. You don't need a textbook for this class. Here are 3 recommended, 3 books that would be useful if you're interested. But I'm going to make this a standalone class, so my goal is just to make everything that you need to know, make sure it comes up in class, and what I'm hoping for you to be able to do is just, and I'm going to try to make assignments that make this easy or whatever, as easy as possible. But I just want you to remember all the stuff I say in class well, and the problems are going to basically be the kind of example problems that we talk about in class and that sort of thing. The way I think of it, in classes where you have textbook reading to do, that's quite a bit of material that you're being asked to absorb, like say over the course of a semester, you're assigned 200 pages of reading in a textbook. I'm assigning 0 pages of reading in a textbook. So right there, that saves you a lot of time, But the trade-off is what I want you to do is spend that same amount of time just understanding the stuff I say in class really well. And every day I'm going to give you an assignment, and part of that assignment is going to be reading back over your notes for the day. And part of that assignment is also going to be, it'll give a previous, not at first, right when we're starting, but later on, it'll say like read today's notes and work through the example problems for today. And then it'll also say go back to, January 13th or whatever. Well, that's a Saturday, but, go back to this day, read those notes, go through those example problems. And so I'm going to try to sort of walk you through reviewing stuff to try to help you remember this stuff. But I want you to know what I say well, and I want you to try to understand it, understand the problems well. Oh, Meredith, I think it's the case, again, that they don't have access to D2L yet. Mm-hmm. Oh, okay. Mm-hmm. Okay. So, so for the assignment today, yeah, it's a nuisance. So for today, is it okay if I email you stuff and you can distribute it to them like an assignment and stuff, and hopefully by Wednesday it'll be done? Okay. Okay. We haven't talked about that yet, but right. So that was my first. That's my first guess or whatever at office hours that would work. Do you think that might work for you? Okay. Oh, that's right. You told me that. Okay. I see. Okay. Tuesday and Thursday. Yeah. Okay. Yes. Sure. Okay. So you don't need any textbooks, but you do need these two things. You need a good calculator. I'm sure all of you have like a graphing calculator or something. If you don't have a graphing calculator, you at least need one that does. Oh, I like it, but you're going to probably want a hand calculator too. Yeah. Yes. Yeah, you don't, in this class, you won't need a calculator for anything except, you know, calculations and sine and cosine. You don't need to use the graphing functions and stuff like that for anything. Okay, prerequisites, co-requisites. You guys don't have to worry about that. The website is that D2L website, and like I said, everything that every material that you need is going to be posted on there. So, you know, be in the habit of looking at that every day or something. Just in the morning, see if there's anything new, that sort of stuff. Here are the topics. I'm not going to go into that because most of that stuff doesn't probably mean a ton to you right now. And so let's go on to how I'm going to grade this class. So first of all, you'll notice that the grading scale looks higher than you're used to or whatever. That's really not, a lot of people at first, that makes them nervous, but that's really not that. I mean, I think you'll find like at least as many people get A's in this class as any other class you take, at least as many get B's. And if it turns out that some of my tests were harder than I meant them to be, and based on that grading scale, only 2 people in the class would get A's or something, then I would relax those grades. But for the most part, those are the cutoffs. Usually those are the cutoffs that it'll be. The reason that the grading scale in my classes is higher than in most classes is because, I just really focus on, I want you to understand the stuff I say in class well. I want you to understand the example problems I do in class and the homework problems you do well. And if you do that, the problems that I put on the exams are going to look very familiar. It's not going to be the same problems, but it's going to use exactly the same type of thought process that you use on the homework problems. So because of the kind of tests I give, and it also, I always give you tons of time on the test, so you have plenty of, like, you're not racing against the clock to get it done. I still find that that's really not, like, I'm not actually being very, like, strict, hard with that. That's just sort of the way I set the class up. The weighting for the grade is going to be 50% exams, 30% assignments, 10% exams on the stuff that we're doing in labs, and then 10% quizzes. And so that adds up to 100. That's great. That's perfect. Yeah, well, the A's go to 92, but the class has 156% to start with, so it's actually not that hard. So now I'm going to just go through each one of those categories and talk in detail about them. We'll start with exams, talk about assignments, and all that stuff. Anybody have any questions yet about the grading or the structure of the class or how to get in touch with me or anything like that? Yep. Yes. But like, I think right before a bunch of you came in, someone asked me what the labs are like. Physics labs are usually like you roll a ball down a ramp and measure how long it takes and use that to measure the acceleration, calculate this. And, mine, I'll have a few that are that way, but the labs in this class are going to be mostly just intuition exercises, just trying to get to the point where you could see something happen. You watch a airplane make an arc through the sky, and based on that, you could say, okay, at this instant, the velocity is this direction, the acceleration is this direction, the total force acting on it is in this direction. That's the kind of intuition I'm talking about. And so in class, we're going to be mainly doing calculations, but in lab, we're going to be focusing on this sort of intuition that then you can use to kind of sanity check your calculations, or just or just like I was saying, look at something and have a sense of what's going on. Yep. No. Did you in another class? Oh, okay. Yes. No. It's all going to be 7:50 to 9:35. No, the classes are in here, and then the labs are. Meredith will take you there on Friday, but over in Normandale. Yes. In this class. Yep. Are you taking chemistry right now too? Okay. You're just taking Calc 2 in this. Any other questions? Okay, there are 4 exams. The dates of the exams are listed here. I know all of you have busy schedules, and your days aren't as flexible as most like college students, because you have to go to class at high school, you have extracurriculars activities and stuff. Most of you can't drive yet, I don't think, right? So I know that all that stuff makes it harder to do makeups, but this is the starting schedule for the exams. If you would, look at your schedules as soon as you can, and if you can't make it to one of these exams or something, just let me know as soon as possible. That's all. I mean, I can be flexible with you guys. The exams, the first 3 are all going to be on Wednesdays, and then the last exam is going to be on Friday, Star Wars Day, because of how much Meredith loves Star Wars. And also because it's the last day of class. Coincidentally. That's your final, yeah. And it doesn't say this in here, but each one of these exams is cumulative up to that point. So each one of these is a final up to that point, And like I said, like part of your assignments, I'm going to, every problem I assign, I'm going to assign twice the same problem. That's probably, you're not so used to that, but it'll be like, so you'll have an assignment for Wednesday, and you'll do a couple of problems or whatever. And then later on, I'll reassign those same problems. And like I said, with the reading of the class notes, I'll say read through today's class notes and read through the class notes from this previous day. And so, yeah, it's important to me that you keep reminding yourself about the old stuff we've been doing, and so that's what the exams reflect. Yeah. No, the reviews are just supposed to be like you redoing those problems and rereading those notes. I mean, you can always ask me questions, but no, we're not going to do like reviews before the test. Any other questions? Okay. The assignments, every class, it says daily. That by daily, I mean every class. So, like after class today, I'll give you an assignment that you need to turn in on Wednesday. Usually the ones for the assignments for Monday and Wednesday, how am I going to do this? I can't remember. I think I guess I only give assignments on Mondays and Wednesdays, I think. And so the assignment for Wednesday, the assignment for Monday is a 2-day assignment. The one for Wednesday is a 5-day assignment. So I'll give you more problems on Wednesdays, not too much to do on Mondays. Every problem is going to be assigned twice during the semester. And so, again, it's just sort of that same idea of like the stuff I want you to know it well. Trade-off is I'm not going to give you as much stuff to know as other instructors would. Yep.
When you assign a problem twice, would it be like out of place?
It's out of place, yeah.
Oh.
That's right. So it'll say, so I'm going to give you PDFs with all the problems for the semester on them. And it'll say like the assignment for Monday, January 8th, do problems 1 through 8 or something from particle kinematics along a line or something. And you'll do those. But then it'll also say, so that'll be the first part of the assignment. The second part of the assignment will say, do, some earlier set of problems, numbers 2 through 10 even or something. And so it's just going to keep making you like, yeah. So if you go back to those and you're like, God, I don't remember how to do this, then you're going to have to go back and like reread the notes a little bit and whatever. But that's just all part of like learning this material well. And usually, I don't know if this is true with your class, but most of the time, most of the people in the class take the AP test at the end. And so in the AP test, you have to know everything. So you might as well start trying to store it all in your permanent memory, as early as possible. That's the way I look at it. And with these assignments, the appearance of your assignments is going to count as part of your grade in a few different ways. It needs to be legible. And I know, people have different levels of legibility in their handwriting. I'm not too worried about that, but you should. But yeah, I'm going to expect this to be not difficult for me to read. I expect the figures, and there are going to be, as we go on, you're going to have to draw more and more like diagrams and stuff. You don't have to use straight edges, or it doesn't have to be like real careful, but I should be able to tell from looking at your diagrams, for example, what lines are parallel, what lines are perpendicular, what lines are neither of those two. So the care that you put into your assignments is going to be part of the grade. I just think it's a good habit to get into now. And if you turn in assignments that like you take out of your pocket to give to me or whatever, you're going to lose points for that, you know, not because it means that you understand physics any worse, but just because I think that's a bad habit to get into early, and so I'm going to try to nudge you out of those habits. Any questions about assignments? So at the start of class, every class you'll turn in your assignments. I'll hopefully hand assignments back to you. And like I said, your schedules are crazy busy. I've never seen schedules like the schedules you take. And so I know there'll be times when you just can't get to the assignment. And if you just come up and, you know, ask me if you can turn the Wednesday assignment in for Friday instead or whatever, I'm always going to say yes. But what you don't want to do is get behind. You know, if you get behind a day, then you need to spend the weekend making sure you're back on track. If for 2 weeks every assignment you turn in is late, it's going to, you know, I probably would let you do that, but it's going to hurt your ability to be ready for the tests. Okay. The second thing, oh, you know what I forgot to say? So required materials, I got sidetracked on the calculator. I also want you to get a 3-ring binder. Look at that hole punch. That's a great hole punch. That was like a magic trick. Oh yeah, that's great. So I skipped it. Oh really? Your moment to shine, and I almost totally missed it. It does not have to be 3-ring. If you have a 4-ring binder or something, I'm not against a different number of rings. But I want you to put. So here's what I want in your binder. I want all of your notes that you take in class, and if you miss class, I want you to print out my notes and put that in there, or watch the video and take notes and put that in there. So I want notes for every single class, and I want all your assignments, the problems that are given and the solutions for the assignments. I want those in there. And after I hand back your exams, I want those in there. Okay, so I want you to, at the end of this class, I want you to have a binder that just summarizes the entire class, because it's a really useful resource for later. Okay, and if I ask to see your binder and you don't have it, I'm going to make you run without a coat on all the way around the whole set of parking lots. Okay, like laps. Yeah. So okay, no. So don't use the binder thing as a. I'm not going to make you do that. So it won't help you get in shape. But you, yeah, next time. That'll help you so much next time you race Grace Ping. Isn't her sister like faster than her now? Oh, okay. Oh, I see. Okay. Yeah, sure. Yeah. I I I used to be a distance runner when my body shape was very different, and yeah, I totally follow that stuff. Do you know in 1991 I was the state champion 3,200 meters in Class AA. Yes, I was. Thank you. It was 2 miles, so that would not be a good time. That would be a very strategic race. Yeah, it was. Actually, it's funny. Like back then, uh, it was sort of a lull in the quality of. So, so yeah, the times were way slower than it. But 9:27 was my time. But yeah, like now it always takes like 9:0 something, and it just wasn't the case back then. Yeah, right. It's amazing. Yeah, it was different back then. Lucky for me. Um, okay, what were we talking about? Oh, the binders. So I won't really make you run laps, but you should put one of these binders together. Okay, the lab exams. Like I said, the labs are going to be mostly like exercises in intuition about physics. Um, and so you're going to be sort of filling out worksheets in all the labs. And the lab exams are going to be having to do problems similar to the problems that you're doing in the labs. So to get ready for the lab exams, uh, you just need to go back through the labs, and they'll all be posted on D2L, but you should take good notes on what you're doing for each one of the labs so you can go back and review for these lab exams. Um, there's 3 total lab exams. They add up to a total of 10% of your grade. So each one, it's not that big a deal grade wise, and usually people do pretty well on those anyways. But it's just a way for me to make you go back and review your lab notes. Um, and those are the dates of the lab exams. They're all on Fridays. Oh no, that doesn't make any sense. All right, there's the first mistake on the syllabus. Right now I have uh, the last exam and the last lab exam on the same day. Let's not do that. Okay, so I'll fix that and give you an updated version of the syllabus. Uh, yeah, that's a good question. Well, I need to think about what the schedule is going to be, but there's only 3 of them. So, um, any questions about labs or lab exams? Yep. The labs are every Friday, and if we don't have class on Friday, we'll just skip it for that week. Any other questions about the labs? Okay, quizzes. Um, so Friday is lab day, and the start of every Friday lab day is going to be like about a 10-minute quiz on it's going to ask you questions about the lectures since the last quiz and ask you to reproduce problems that were assigned since the last quiz. So it's just more of me trying to make sure that you're not just sort of skimming through the notes or taking the notes, but you're actually going back and making sure you understand stuff and making sure you remember the assignment problems that you did and that kind of stuff. There's no real point in doing all this work if you're not going to remember it. And so I'm just trying to make sure that you're making an effort to remember it all. And the trade-off that you get is that it reduces the amount of reading you have to do and it reduces the total number of problems you have to do. I just want you to remember the ones you do. The quizzes, I guess, are the one thing in the class that are not cumulative. So the quizzes are just on the stuff from the last week. Um, Everything else, you need to go back from the start of the class and review for it. Any questions about the quizzes? And then this is cheating policy, some stuff of mine, some stuff from Normandale. I don't know, maybe. That's a good question. I've never yet had any problem with like real clear cheating with Dimensions Academy. The one thing where, and this is sort of gets into a gray area, is I think I have had times where people have turned in assignments that were, it's sort of a continuum. Like, did you copy this assignment? Like, well, kind of, but yeah. And it's a little hard to sort out what it means for it to be your. That's right. Yep. That's right. Yep. So to me, so on here is the distinction that I make between copying and doing your own work. Working together on stuff is great, but I don't want you to turn in any stuff that that you wrote down while you were working with somebody else. Okay, so basically, like, work together on stuff. Have them, if they understand something and you don't, have them explain it to you. But later, like, the understanding you gain needs to be good enough that you can go back without checking the notes every 10 seconds and write up the solution to the problem. So I don't care, like, the basic idea is I don't care how the understanding of that problem gets in your head. Working together is a great thing to get in the habit of. But I expect it to at some point be in your head before you write down the paper that comes to me. If you're filling out your assignment, like, okay, so x equals 2x, y equals 2x, and then like, oh, what do you do there? And you look over, okay, yeah. What do you do here? Then that problem, the understanding of how to do that problem has never been in your head. You're just copying someone else's stuff. So that to me is the difference. Okay. Anybody have any questions about? So cheating, obviously, like on a test, looking at someone else, the test of someone next to you that's pretty clear cheating. I've never had a problem with that in Dimensions Academy, so I'm not too worried about that. But also, I think it's important to get used to drawing this line in your head between what it means to work together with someone but still turn in your own work, and obviously, like, as you go on, in a couple of years in college, any kind of cheating related thing is taken very seriously by colleges and universities. And even if to you, you're like, that wasn't cheating, I was doing this or whatever. If you get the wrong professor who is really in a mood for cracking down on that stuff, it can cause you a lot of problems, So it's in your best interest to get in the habit of drawing a clear line about this stuff now, Any questions about that? Okay. General policies and comments. Everything is going to be on D2L. So, like I said, get in the habit of checking D2L in sort of a regular schedule. I would say once a day, And the second thing is, so it says, treat me and your classmates respectfully. We're going to do a lot of times during classes, I'll stop lecturing, you'll go up to the whiteboards and work on stuff in little groups. And I think this class is going to be fun, and there'll be some like joking and whatever, and that's great. This is another place where it's sort of hard to draw like a clear line. Like, we're all like joking around, and then it's like people are still laughing or talking about this, or or even just still talking about the work you've been doing on the board when I come back and start the lecture. I mean, when that happens, I'll just like say, okay, like let's quiet down, get it back up here. I need to talk about this. So please try to just, when I'm lecturing, be quiet, let me talk. If you have a question for me, that's great. And, raise your hand or whatever. But even though we're going to be doing a lot of interactive stuff, I still need to have sort of control of the class when I'm trying to explain stuff. Any questions about that? Okay. Well, so this is the format of this class. I'm always going to go for, the first half of the class, then we'll take a 5 or 10 minute break. I can't remember how long. Let's try 10 today. Is that too long? 10 minutes? That's the right amount? Okay, 10-minute break, and then we'll do the second half of class. So it's sort of like 2 50-minute classes. Okay, so let's take a break, come back. I'm going to start right at 8:45. Okay? Okay. So now we can start to get into some physics for the first time. But before we do that, I want to talk a little bit about like time commitment for this class. So the context for this time commitment is, I know you all have the most horrible, painful schedules I've ever seen in my life. The basic answer for how much like outside of class time you're supposed to put into a college class is whatever number of credits. Well, basically for every hour you spend in class, you should spend 2 to 3 hours outside of class. Okay, so that's a lot. So let's think about what that means in this class. This is a 5-credit class. Subtract off the lab, and the lecture is 4 credits. Okay, so 4 hours of class time per week. 2 times 4 is 8 hours. 3 times 4 is 12 hours. So somewhere between 8 and 12 hours a week outside of class is what is just the overall, everyone agrees, answer for how much time you should spend on this class. Okay, that's a lot. I'm going to bank a little bit on what I know is your ability to learn things pretty quickly. And let's just say we're on the short end of that. Okay, so 8 hours a week outside of class. Basically an hour, a little over an hour every day, 7 days a week. Okay. I think if you spend an hour every day on this class, you'll do great. Okay. An hour a day, 7 days a week means if you miss a day, like you're busy all day Sunday doing something else or whatever, that's time that you have to make up. So there's a distinction between an hour every day and an hour most days, An hour every day adds up to 7 hours a week. An hour most days adds up to 4 hours a week. You know what I mean? So the expected time commitment. One hour a day outside of class. Okay. I think for most of you, that'll do it, That's not a guarantee that that's going to be enough for everybody. Some people have to spend more time than that, but this is what you should count on having to do. Okay. Um, okay, so the first topic that we're going to go into is kinematics of particle along a line. You all know what a line is. Okay, good. But we have to talk about what kinematics means, and we have to talk about what a particle is. So first, kinematics. Kinematics means describing motion. Without um, addressing the causes of the motion. So for us, this is going to be relationships. This is an abbreviation for relationships between position, velocity, acceleration, and time. One way you can think of this is it's all the things that you could measure from a very careful video of the motion of an object. You could measure, if you had like distance measures along the wall, you could see how long it took for it to get from here to here and from here to here, and how fast it was moving and how much that speed was changing and things like that. What you couldn't measure from a video is the mass of the object or the forces that are applied to the object. Those are the causes of the motion, and we're not getting into that yet. Question? Okay. So for now, we're only dealing with kinematics. We're not going to be talking about forces or mass yet. That's going to be when we move on to the next topic. And then particles. Do you have a feel for what you use the word particles to mean? So yes, small. The interesting thing is we're going to use the idea of a particle to describe a lot of things that by almost no measure are small. And so there is some truth to that fact that a particle is a small thing. But like, for example, when you do planetary physics, you treat planets as particles, and those aren't very small. So what it really has to do with is just how you use the math to model the thing. And that's based on what you want to know about the object. So particle is an object that's treated as having no length dimensions. That's the small part. In other words, you can think of it as existing just at a single point. But if you think about what it means for an object to, like, if you say an object is facing towards the door, what does that mean? If I'm facing towards the door, what does that mean? It means one part of me you know, the face part, is in the direction of the door, and the back of me is facing opposite the door. So what does orientation mean for an object that is just a single point? If there's no length dimensions, you can't make any distinction between the face part and the back part, right? And so if you are not treating an object as having any length dimension, you also can't describe any orientation of the object. So this way of modeling the object as having no length dimensions requires that the object has no orientation. So in other words, you can't treat an object as a particle if you want to know anything about its orientation. When you do planetary physics, you usually represent the planets as particles because you're not really trying to figure out where the Jupiter's spot is. You're trying to figure out where the center of the planet is at a certain time. Yep. Yeah, that's right. And so that's why if you're doing the physics of planets, it's just that you don't care about which way the planet is facing, that you say, okay, I'm just going to treat it as a particle. Whereas something small, like what's going to happen if I put this stylus here and bang on the front of it? Well, it's going to flip over in the air, and we might want to know something about how its orientation is going to change as it flips through the air. And so even though this is a lot smaller than Jupiter, for this problem, we can't treat this as a particle. Yep.
To treat something as a particle, does it have to be round or symmetrical?
Nope. It has to. So that's a good question. So when you treat something as a particle, what you're calling the point where its location has to be the center of mass of the object, and anything has a center of mass. It's easier to imagine what the center of mass is if it's a sphere or whatever. But everything has a center of mass. It just can be complicated to calculate for weird shapes. Okay, so we're going to be dealing with position, velocity, acceleration, and time. And so I need to define those quantities. And so I'm going to start with position. And position is going to be given by a number. And so we have this question that we have to start with. At a given object location, what does it take to assign that location a number? Well, one thing is you need a length scale. That's not really what I'm talking about here. So let's just say besides a length scale. There are two things that need to be defined. So say the stylus is here, And let's say that our unit of measurement, our unit of length is meters. Is that stylus at location 7 meters, or location -1 meter, or at 0 meters? Yeah, you need some kind of reference for both, in order to do that. And I'm going to break that reference up into two separate things. You need a reference location, like the 0 position. I'll call that the location corresponding to the 0 position. Once we go into 2 and 3D, what we'll be talking about is the origin. And if we're talking about particles for now that are only moving in a line, we need one more thing. So say that's there, and we say our 0 position is this. The distance between those is something like 1 meter. Let's say that's 1 meter. What else do we need to know what the location of that is? Yep. A direction. Yeah, we need to know. And there are two possible directions. There's a positive direction and a negative direction. We need to choose, is this what we're going to call positive, or is this what we're going to call positive? And either of those choices is perfectly fine, but your answers are going to depend on which of those you chose. So we also have to choose a direction corresponding to positive. That's right. Their locations can have directions. They just don't have a face and a butt. You know, you can't tell. So if you're treating this as a particle, it just means, so its location is defined. We just can't make a distinction between this and this. Yeah. Okay. And let's talk about units for a second. So the units for position always have to be units of length. And there are many units of length: inches, feet, miles, meters. The SI units are meters. And so most of the calculations that we'll do are going to be in terms of meters. And that's represented with a lowercase m. Bless you. Okay, so let's think. Actually, before I do this example, there's one more thing I want to talk about. Normally, what we want for the position is, so we want to express position as a function of time. And to do that, we need to make one more choice. We need to define one more thing. Okay, so so now we know this is our 0 position, this is the particle we're looking at. Let's say we call the positive direction this way. in order to say that, so this thing has a position of positive 1 meter. If we want to represent that position as a function of time, we also need to be able to assign a numeric time to this instant. So what do we need to do to assign numeric time to a physical instant? Well, you know, it doesn't have to have anything to do with any other position, but we just need to choose an instant that basically our stopwatch goes on. Okay, we need to choose an instant that corresponds to 0 time.
So this is part 2 of
What? Yes, that's right. Yep. And we don't have to choose a positive direction for time because time only goes in one direction. So once you've made these 3 choices, once you've chosen, what order did I go in? The 0 position, the positive direction, and the 0 time. You can represent position as a function of time. So let's think about how that works in sort of a simple case. So this is the shore. And there's the water. And then there's a raft out here in the water. And then a little farther, there's a buoy in the water. And a swimmer is standing on the shore here. Okay, and let's say that it's 50 meters from the shore where the swimmer is starting to the raft. And then 25 meters from the raft to the buoy. And let's say that the swimmer takes the swimmer goes from shore to the raft in 2 minutes. And then from the raft to the buoy in 1 minute. And then gets tired and it takes 2 minutes to get back from the buoy to the raft. Okay, so the swimmer goes from here to here to here, back to here. Okay. And what the swimmer does doesn't have anything to do with our choices of those 3, you know, the 0 position, the positive direction, and the 0 time, right? The swimmer doesn't care about that at all. The swimmer doesn't even know we're hiding behind this tree measuring its times carefully, secretly. But in order for us to put numbers to this stuff, so let's say that we want to draw a position versus time graph. In order for us to put numbers on all these things, we have to make these choices of the 0 position, 0 time, positive direction. So first, let's choose the 0 position shore, the positive direction to the right, out towards the buoy, and then the 0 time when the swimmer starts swimming. Okay, I'll draw this picture again here. So here's the raft. Here's the buoy. Here's the shore. The 3 points that we care about are here, here, and here. And let's just start to label these locations. Our 0 position is at the shore, so numerically, the value of the shore is 0. The positive direction is to the right, and it's 50 meters distance between the shore and the raft. So numerically, what would be the location at the raft? Yep, positive 50. And then it's 25 more meters in the positive direction to get to the buoy. So what's the label for the buoy? 75. And so the swimmer goes from 0 to 50 to 75 and then back to 50. Let me draw a position versus time graph. We're always going to put position on the y-axis, time on the x-axis. And when the swimmer leaves the shore, what's the time? 0. Yep. So this is where the swimmer is at location 0. What's the time when the swimmer is at location 50? Yep, 2. What's the time when the swimmer is at 75? 3. Yep. That's right. Yep, perfect. And so, and the labels here that matter are going to be 0 position, 50 position, 75 position. That's right. That's right. So the swimmer in this case starts at 0, gets to 50 there, 75 there, and then back to 50 there. And we don't know anything really about what's happening in between those points, but I just sort of made them smooth. So that's a position versus time graph, but that is not like a universal position versus time graph. It's just specifically the one that we have from our choices of 0 position, positive direction, and 0 time. Okay, so let's try the same idea, but this time we'll have the 0 position at the raft, the positive direction toward the shore, toward the left, and the 0 time 1 minute before the swimmer leaves the shore. And we want to draw a position versus time graph. Okay, so we have this location, and this location. We chose this time a 0 position to be at the raft. So the numerical location of the raft is 0. And we chose a positive direction this way. The distance between the shore and the raft is 50 meters. So what's the numeric location of the shore? Well, we switched the positive direction. So this is going to be positive 50. And now, since the positive direction's toward the shore and the 0's at the raft, the location of the buoy is in the negative direction from the 0. And the distance from 0 to the buoy is 25 meters. So the location here is going to be negative 25. Any questions about that? Okay, so the position versus time graph is going to have the relevant positions are 0, positive 50, and negative 25. Now we have to think about when the swimmer is going to be at these locations. So basically what you're always thinking about is what's the stopwatch going to say at these different instants? What's the stopwatch going to say the instant that the swimmer leaves the shore? Yeah, positive 1. So this time the swimmer starts here. What's the stopwatch going to say when the swimmer gets to the raft? 3. The buoy? 4, yep. And back to the raft? 6, yep. This is in, I didn't say this before, but this is position in meters. This is time in minutes. And so the swimmer is going to start at positive 50 at time 1 minute. At time 3 minutes, the swimmer is going to get to the raft. That's 0 location. At 4 minutes, the swimmer is going to get to the location negative 25. And then at 6 minutes, the swimmer is going to get back to location 0. And this position versus time graph looks pretty different from this one. There are certain similarities, but you get a graph that, so compared to the one before, this is shifted horizontally. What caused this horizontal shift? Yeah, the time, when we chose time equals 0. It's also shifted vertically. What caused the vertical shift? The position equals 0. And then it's also flipped. What caused the flip? The direction. Yeah, choosing a different direction for positive. So the answers we're going to get are always going to depend on these choices of positive direction, 0 position, 0 time. Okay. So we'll do problems where some of the answers you'll give might not be the same as the answers that someone else gives because you just happen to make different choices for these three choices. But those different answers are still right. You just made different assumptions. Yep. Location, well, position, I think probably sometimes I'll use them interchangeably, but really technically location is a physical thing. Like location is this, and position is a number. Position is positive 7 meters, whereas location is the object is sitting right here. One thing to notice is, I didn't say the stopwatch is turned on a minute after the person starts swimming. Mathematically, there wouldn't be any problem with that, but just in physics, it's sort of a agreed upon thing that we're never going to use negative times. There's no reason that wouldn't work with the math, but notice we just won't ever use negative times. And that means that if you ever get an answer that that gives a negative time for something, it means something went wrong in your calculation. Okay. So since you can't give position as a function of time until you've made these three choices, if you ever in a problem are given position as a function of time, it means that those choices have already been made. Okay? There's no way to relate numerical position to a numerical time without already having made those choices. Usually for us, position will be given as a smooth function of time. Anyone remember what smooth means? Yep. Yes. And continuous and differentiable as many times as you take derivatives. So if your problem only uses 3 derivatives, then it means it's differentiable at least 3 times. Yep, that's right. It depends on the interval you're looking at, but you can't have any of those jagged non-differentiable points inside the interval you're looking at. So, for example, we'll see stuff like the position as a function of time is equal to 2t cubed minus 20. So then, obviously, like if you want to know what the position is at 1 second, just plug 1 into that, and you get negative 18. And position at time equals 0 is negative 20, Okay, so that's position. Now let's talk about what velocity means. And the velocity that's going to be important to us is instantaneous velocity. And there's a nice simple definition of velocity once position is defined. Velocity as a function of time is the time derivative of the position vector. We're not talking about vectors yet, but the position. And there's a shorthand that people use when you take time derivatives. I don't know if this has come up at all in your math classes. I think maybe they don't tend to talk about it this way, but you'll see this a lot. Instead of using a prime, they use a dot over the variable. So any variable with a dot over it like that means first derivative with respect to time. And then if you don't have to write this down, but this will come up later. If you see something with two dots over it, that means a second derivative with respect to time. The primes?
Yeah.
That's right. So primes are for something independent variable other than t. Dots are for t. I guess because in physics, the derivatives with respect to time are so come up so often that you want a way to differentiate. You want a way to separate those kind of things from, make it very clear to yourself that that's different than taking a derivative with respect to a position or something. I don't think I would probably take points off, but I would probably circle it or whatever, Okay, so instantaneous velocity. Has units always that are a unit of length over a unit of time. And so SI units for velocity are meters per second. Yeah, we'll use some of that stuff. Usually we'll just convert to SI units as part of the problem. And you've done all unit conversion and stuff right in your chemistry class. So it's no different here. Okay, so let's say that we're given a particle's motion. Position as a function of time is equal to negative 5t squared plus 5. Yeah. And we want to know what's the velocity as a function of time. Well, the velocity is just equal to the time derivative of the position. And that's equal to negative 10t plus 0. So this is a function that gives you the velocity at any instant. And so based on this, we could say the velocity at time equals 1 second is equal to negative 10. The velocity at 5 seconds is equal to negative 50. Yep. That's like 5 seconds. Okay, so intuitively, velocity at an instant gives two pieces of information. The absolute value of the velocity is the speed. That instant. And the sign is the direction the object is moving at that instant. So comparing these two instants, instant 1 second and instant 5 seconds, in which of those cases is the object moving faster? At the lower one, at 5 seconds it's moving faster because the absolute value is bigger, the speed is higher. And then in both of these cases, the object is moving in the direction that was defined as negative. Any questions about that? Oh, we're done. Okay. Well, I will send a short assignment of some kind, maybe like a calculus review or something, to Meredith, and she'll get it to you. And see you Wednesday.